Hey, in today's video I will show you the basics of creating a fully working trading algorithm for cryptocurrencies, and we will even connect it to a broker called Alpaca. The advantage of using Alpaca is that it offers a very nice API in order to do automated trading. So before diving into the code, we will have to create a free brokerage account in Alpaca Markets. Oh, I just realized that it would have been a good idea to see if they offer some affiliate link in order for me to make money, but that's okay. It's too late for that now. So go ahead and register. There's nothing difficult in the process. So I'll just skip it and go straight into the account. So once you've logged into your new Alpaca account, you will be able to choose between the live trading or the paper account. I urge you to start using the paper account so that you can reduce the cost of learning. So let's go right into your paper trading account, and here under your API keys, go to View, click on Regenerate Key. Yeah, and go ahead and copy and paste the API key and the secret key. So let's already go ahead and start a new Python file. In my case, I'm going to use a Jupyter notebook, but you can also go ahead and create just a blank Python file. If you don't already have a Alpaca Trade API installed, go ahead and open a terminal and type pip install Alpaca Trade API. Okay, once we've done that, let's continue and let's start importing things that we will be using in this tutorial. From Alpaca Trade API.rest import rest and time frame. What else? Import pandas as PD. Import with just one P. There you go. And now let's create a few global variables like the base URL, the key ID, and the secret key. The base URL is going to be this one. So let's copy it and paste it. We will do the same with the key ID and the secret key. Normally you would have to hide these keys since they provide access to the account, but this is just a newly created account that I'm using for this tutorial, and I'm also using just the paper trading keys, so there's no risk in me showing the strings. And let's go ahead and create a connection. API equal lowercase API equals rest, where the key ID equals the key ID, secret key equals the secret key, and the what else? The base URL is just the base URL. Let's test it out and get some historical prices for, say, Bitcoin. We'll call it bars, and API.get crypto bars. The asset that we want is BTC USD. And the time frame is going to be timeframe.minute. And the API returns a few components, but we just want to keep the data frame. So let's do that, and also print bars.head. As you can see, we are receiving price data from multiple exchanges. CBSE is the Coinbase exchange, and FTXU is, I don't know what it stands for, but it's the exchange where Alpaca routes our orders. For now, we will be using the CBSE, Coinbase, since they have more liquidity, and sometimes FTXU that has missing bars because it's more illiquid. But for now, let's just continue and see how we would place an order. Order by equals to API.submit order. Underscore order, BTC USD, and quantity is going to be 1, and the site is going to be buy. In this case, it's just a market order, so it will get filled. And let's go ahead and print it. Print order buy. So you can see that we created a buy order for 1 Bitcoin, which is quite a lot. It's a market order type. And where do we have the symbol? Sorry, where do we have the symbol? In here, BTC USD. It is just as easy to also place sell orders. We just have to change this for sell. And there we go. Now we solved it. And if we go back to our Alpaca, you will see that we placed the buy order and the sell order, and that they are already both filled. And we even lost some money, so that's good. It will help you get used to that. Let's continue and see how we would find out our current position in an asset. We can get that by doing api.get_position BTC USD. And as you can see, it returns an error saying that position does not exist. This is quite an annoying error. It would be nicer if it just returned 0, but we can find a way around this as follows. Positions equals to api.list positions, and then we will declare a variable called position equals to 0, and then let's create a loop over all the positions that we have and see if one corresponds to Bitcoin. So for p in positions, if p dot symbol equals BTC USD, then position underscore quantity equals p dot quantity. And I already know that it returns a string and not a number, so I'll already convert it in here to a float. And let's print position quantity. It's not defined. Quantity 0. That's nicer than an error. And if we go back and place another buy order for 1 Bitcoin, we should now be getting a 1. And it's nice to know that at least this is working. Let's already go ahead and create an algorithm. Throughout this video, we will create 2 algorithms. The first one is going to be just very simple in order to show you how to create an algorithm. And the second one will have some more interesting rules. So let's get started with the first algorithm. And let's also convert this into a function in order to reuse it later. Define get position and the symbol indent all of this. And instead of printing it, let's return position QTY. There's an improvement. Let's do this. Return 0. Let's get rid of this. And if the position equals to the symbol, not just Bitcoin, the symbol given here as a parameter, then instead of storing it into position quantity, we'll just go ahead and return it, because we don't want to keep on iterating all over the positions list unnecessarily. So let's try it out. Get position of ETH USD. That's Ethereum. 0. That's nice. BTC USD. 1. That's even nicer. And let's continue with the strategy. It's going to be a very stupid strategy where we just go ahead and buy if we don't hold a position, and we flip a coin, and if it turns out to be true or heads. And we are going to sell if we already have a position in the asset and the coin turns out to be false or tails. So in order to do that, let's go ahead and import random and start iterating while true. First, we will get our current position in the symbol. Position equals get position. That's a function that we just created. And symbol. And we will specify the symbol outside of the while loop. BTC USD. That's right. So let's flip a coin and resort to what the gods tell us. Let's say gods say buy equals to, I hope I'm not offending anyone, random dot choice, and then from a list of true or false. It will return one of both. So let's check if we should buy. Check if we should buy. If position equals 0 and gods say buy, then let's print. In order to debug, let's do a lot of prints. The gods have spoken. Spoken. There you go. And what else? Print. Let's do an F string of what we're doing. Symbol is symbol and side is buy and quantity is 1. Let's do that. API.submit order symbol QTY equals 1, side equals buy. What else? Let's check if we should sell. Elif. Check if we should sell. Else if position is greater than 0 and gods say buy equals to false, so they want us to sell, then again the gods have spoken. Let's copy and paste that. Pew, pew. There you go. The gods have spoken, but this time they want us to sell. So we will sell. Side sell. There we go. And now let's print. Let's do a pause. Time.sleep. I don't know. Import time. This is going to insert a pause. Let's sleep for, I don't know, 5 seconds. Let's print what we have done. Finished iteration. Let's wait for the gods to manifest again. And let's also print a separator. This is going to print 20 of these. So let's test it. I'm sure it won't work. Oh, that's cool. The gods have spoken. Symbol side sell. That's okay. That's because we had one. Side buy. Finished iteration. Nothing happened. So we sold, bought, and now we are selling again. We are waiting for 5 seconds. The gods didn't tell us to do anything, so we just stay still. Now they told us to buy, so we bought. So basically what we have is an infinite loop that checks every 5 seconds if the gods want us to buy or sell Bitcoin, and depending on whether we hold the position or not, we obey their wishes. And now that we've gone over this basic while loop, let's go ahead and create a new strategy, but this time a more refined one. So this new bot will be a little more interesting. It will have two moving averages, and we will buy and sell depending on which one is greater than the other. So let's go ahead and import a few functions, a few libraries that we will need. From datetime, import datetime and time delta, import math, and again import time. We already have it, but that's okay. So the symbol is going to be BTC USD. What else? We will have two moving averages. One is going to be a shorter one or fast one, and the other one is going to be slow. So let's call them SMA fast, and this is the number of minutes that we will use to calculate the moving average. The fast one is going to use 12 minutes. The slow one is going to use 24 minutes. And let's also choose the quantity per trade. Quantity per trade equals to 1. Okay, let's create a function to get the data. Well, let's call it define get underscore bars, and it's going to require a symbol, and the bars are going to be api.get crypto bars symbol time frame dot minute, and as before we'll keep the data frame. And now we are going to filter by Coinbase. Bars equals bars, where bars.exchange, check it out, let's see how it was, where bars.exchange equals CBSE, which is Coinbase, equals Coinbase. Let's already go ahead and add the moving averages. So let's do bars SMA fast equals to, let's create the function for that, define get underscore SMA series and periods. And just return series dot rolling periods dot mean. This will return a series with the moving averages of the last n periods. So let's use that, get underscore SMA. Let's send over the bars dot close underscore close, and SMA fast, which is 12. Let's do the same for SMA slow, there you go. And this function just needs to return now, return bars. Great. So let's get started with the while loop. While true, let's first get the data. Bars equals to get bars symbol. Let's continue. Let's check our position. We already have the function for that. That's great. Get underscore position. Underscore position of symbol. That's right. Let's create a function to see if we should buy. So basically we should buy if the SMA fast is greater than the SMA slow, and otherwise if the SMA slow is greater than the SMA fast, we will sell. So let's do a function that just does that. Define, let's call it should buy, and send over the fast and slow. And let's see, return fast is greater than slow. So So it will return true if the fast moving average is higher than the slow one, and otherwise it will return false. So should buy returns that. Let's use it. Buy equals to should buy, and let's send over both bars.sma fast and bars.sma slow. So now we just have to implement the logic. Let's also do a few prints in order to see what should be happening. Print. The symbol is symbol. The side is should buy equals to should buy. No. Buy. There you go. And now I have to close this. So now let's do the proper conditionals. If position equals 0, just once, and buy equals to true, then print f-string, print we should be buying, and let's also buy API.submit order symbol QTY equals to quantity quantity per trade, and side equals to buy. That's nice. And let's do else if position is greater than 0 and buy equals to false, then copy we should be selling. There you go. And let's place the order. And sell. As you might remember, then in the random bot we just inserted a 5-second pause, but now I would like to be a little more specific, and since we are dealing with 1 minute time frames, I would like to check this entire while loop once every minute, but not just once every minute, exactly at the time when a new bar gets closed, so at the minute switch. So I would like to have a function called time.sleep, and let's call it get pause. This does not exist yet, but let's do it. Let's create that function, define get pause, and this is a very interesting function. Check it out. Now equals to datetime.now, and next minute is going to be now.replace second to 0. So right now we are in 30 seconds, and this function is going to replace it by 0. And then we will add 1 minute, time delta minutes equals to 1. So if we are right now, the function would return 8 minutes and 0 seconds. That's the next minute. And if we subtract the now time from the next minute, we will get the pause expressed in seconds that we will have to wait in order to arrive at the next minute exactly. So let's do that. Let's do pause equals to next underscore minute minus now, and from that we will keep the seconds. We don't want it to round down because we might arrive at the same minute but 59 seconds. We want it to go over the next minute, so let's do, instead of rounding down to the nearest integer, let's make sure that we are rounding always up. So let's do math.ceiling let's print the separator like before, times 20. And let's also print the pause in here. We didn't return anything. So print, let's sleep for pause seconds and return pause. And this will return the number that is going to be used here in order to get the pause. So let's test it. It's not working. Get pause seconds is an invalid keyword argument for replace. Microseconds equals to 0. Okay, I found it. It's not seconds, it's just second, and microseconds is microsecond. So let's test again. So we didn't buy. Let's sleep for 1 second. Is that okay? Yeah, it just switched minutes. So now we're going to wait a lot. So I will wait for another minute and see if it's working, but I will pause the video and resume it later. So as you can see right now, we should not be buying, and we still don't hold the asset, so it's not doing anything interesting. But just in order to test it, let's go ahead and manually buy the asset. Let's restart this. Let's go ahead and place an order in here. Let's buy BTC USD. There you go. Let's buy 1 at market value, and let's do that. Okay, so now we have 1. And now we should be selling, and I hope we sold it. Let's go in here. And this takes a few seconds to update. There we go, we sold it. So it seems to be working fine. So I think that pretty much covers what I wanted to show today. And if you have any questions, don't hesitate to leave it in the comments. And also, if you want to have the source code, you can check out the link in the description, and I'll see you on the next one.